everyone, welcome back to the channel. Today we're going to be learning about inverses. So when you look at the inverses, you want to think about a function, and its inverse is essentially undoing that function. So the concept of inverse is that it reverses the action of the original function. So that's kind of where the undoing part comes from. You want to think of that action as reversing. So to check that functions are inverses of each other, you want to check that f g of x is going to equal x, and g f of x is going to equal x. So what does that mean? Well, that means that those are composition of functions, right? One is inside the other. So what we're doing is we're verifying that two functions, f of x and g of x, result in the x, which is the input. So what I want you to think about is, like, if you have a function f and you're trying to check that g is the inverse of f, what you want to do is apply that inverse to f, and it will result in the input, right? So that input is x. So that kind of goes back to the definition of inverses. So that becomes much simpler when you look at an example. So say you have f of x equals 1/2 x plus 9, and then you have another function g of x, which equals x plus 9 divided by 2. You want to check if those two functions are inverses of each other. So the question is, are these functions inverses of each other? And the way to check that is by taking the composition of those two functions. So you want to check that f g of x is going to equal x. And what that means, the function g of x, all of that function, and you're going to input it for x in the f of x function. So we're going to take x plus 9 divided by 2, and we're going to put that in for x in the other function. So we're going to have 1/2 x plus 9 divided by 2 plus 9. Now let's try to do the algebra here. You're just going to multiply. So you're going to have x plus 9 divided by 4 plus 9. Okay, now you want to turn that plus 9 into a common denominator. With the common denominator has to be 4. So we multiply that 9 by 4. What we do to the bottom, we have to do to the top. So we end up with 36 over 4, which simplifies to 9, right? That's just the equivalent fraction. So now we do x plus 9 plus 36 divided by 4. We can combine them because they have common denominators. And then if we simplify, we get x plus 45 divided by 4. We can break those up. We can x divided by 4 plus 45 over 4. That does not equal x. So because the output does not equal x, that means that these functions are not inverses of each other. Now we want to ask, how do you find the inverse of a function? So what we just did was check if two functions are inverses of each other, but now we want to ask, how do we find the actual inverse of a function? And that's fairly simple. All you have to do are these 3 steps. Your first step is to switch the x and the y. And then your second step is going to be to solve for y. And your last step is gonna be to write your final answer in proper notation. So I'll show you what that means in a little bit. Okay, so let's take an example. Let's say that f of x is equal to 4x minus 12. What you want to do first is remember that f of x is the same thing as y. It's the output, and y is always the output. So think about f of x as being the same thing as y. So you want to rewrite that and just put y equals 4x minus 12. Now your first step is to switch x and y. So we're going to swap the variables, and now we're going to have x is equal to 4y minus 12. We're going to solve for y, so we're going to add 12 to each side. So we get x plus 12 equals 4y. Now we're going to divide by 4, and we're going to get x plus 12 divided by 4 is equal to y. Now that left side can be reduced further. We can break each of those up. So x divided by 4 plus 12 divided by 4 equals y. And to simplify, we have x divided by 4 plus 3 is equal to y. Now our last step is to write that in function notation. So we have f inverse of x is going to equal x divided by 4 plus 3. And we're done. So fairly simple, right? Okay, let's try another example. Let's do f of x is equal to 4 minus x squared. Remember that f of x is the same thing as y. You want to switch the variables, so you want to switch x and y. So now we have x equals 4 minus y squared. You want to solve for y, so you want to subtract 4 from both sides. And you're going to end up with x minus 4 is equal to negative y squared. Now you're going to divide by negative 1 on both sides. So you're going to end up with negative x plus 4 is equal to y squared. And your last step is to square root both sides. And when we square root both sides, remember that we have two answers. We have a positive and a negative. So on the left, we'll have plus or minus square root of negative x plus 4 is equal to y. And your last step is to write it in function notation, inverse function notation. So f inverse of x is going to equal to plus or minus negative x plus 4. And you're done. Okay, now there are 3 more things we need to cover, and that's basically everything you have to know about inverses. So one of those things is that if you have a point, let's just call it a comma b, if that point is on the graph of f, then what that means is that for the inverse function, that point is going to become b comma a. So essentially what you're doing is you're swapping the domain and the range for f and the inverse function f inverse. So ultimately that's going to result in your graphs being reflections over the line y equals x. And it's easy to see this in an example. So let's take these points on the table. When you're going to do the inverse, you have to swap AB, and now it becomes BA. So essentially, what I did was take those points from the first tables and swap them. So instead of -2, -3, I have -3, -2. So again, AB becomes BA, and for us, in our example, we have x comma f of x becomes, or gets switched to f of x comma x. So now let's plot these points. So let's start with the original function. We're just going to plot all those points. And then we're going to connect them. This won't be a straight line. It kind of curves. Then we're going to plot the inverse function. And what you notice is that if we included our line y equals x, it's very obvious that the points of f of x are reflections over that line. So take a look at how the points mirror each other, right? When they mirror each other like that, they're essentially reflections. So now let's take a look at the domains. So the domain of x has to do with the x values. The x values are from -2 to 9. And now let's look at the range of f of x. So the range of f of x, that pertains to the y values. So our y values there are from -3 to 6. Okay, now let's take a look at the domain of the inverse function. So again, you look at the x values of the inverse graph, and that becomes points from -3 to 6. And then if we take a look at the range of the inverse function, that becomes points from -2 to 9. And what do you know? Domain and range swap for f and f inverse. The domain of f is the range of f inverse, and the range of f is the domain of f inverse. And there you go. That's literally all you need to know for inverses. So again, please subscribe. Comment any math video requests you have, and join the Teams chat. It's literally free, and I help you there with any math problems you have. So take advantage of this free resource, right? And yeah, good luck in your math class.